Hi there, and welcome back to the latest video in BCIT Technology Teacher Education's Bamboo Barbecue Skewer Truss project. So we've already taken a look at how to model the truss and check out its structural buckling in Fusion 360. And then we came along and designed all of these nifty little nodes right here. And now what we want to do is we want to take those nodes out of Fusion 360 and put them onto our 3D printer. And they'll come out looking something like this. And then the slicer software will be able to generate G code so that we can come down here and we can preview everything that's going to cut. And then we can take that and put it into our 3D printer. There's those flat sides that we left on the bottom of the nodes. And over the course of, well, on the Creality Ender 5s in the shop, it might take a day. On some of the newer, faster 3D printers, maybe a little bit less. Really kind of depends on some of the settings that we put in there. So we're going to take a look at how to set all those settings up. But before we get there, you're going to need Ultimaker Cura on your computer. Now, this is February 2025. I may be using different slicer software later on. You may have different favorite slicer software. All of the slicer software works pretty much the same. But anyway, I'm going to be talking about Ultimaker Cura. It works great with the Creality Ender 5 printers that we have in our shop. So what you're going to do is you're going to Google Ultimaker Cura, and you're going to come in here and you're going to download the latest version of Ultimaker Cura, and you'll put it onto your computer. It runs on Windows, it runs on Mac, it runs on Linux. It's pretty cool, and it's great that Ultimaker makes that available. Not that they really had all that much choice, because the core of it is open source to begin with. Like I say, there's other slicers. They're great. If you want to use your favorite slicer, go right ahead. You know what you're talking about. If you've never done it before, I'm going to be talking about Cura. Okay, so go ahead and download that. And when you install Cura, if you're one of my students at BCIT, you're going to have to tell it what printer you're using. So you're going to set it up, and you're going to tell it that you want to create a file for a Creality Ender 5. And to do that, you'll come into Settings, and you'll go into Printer. And you can see I've already got Creality Ender 5 in there. That's because I've come to Add Printer. And you'll tell it that you're using a non-Ultimaker printer. And you will, where is it in here? Add a non-networked printer. It doesn't have to be an Ultimaker. You'll come down here, look at all of the different printer names. When you get to Creality 3D in February of 2025, we have 3 Creality Ender 5s in the shop. So there we are, the Ender 5. It's not the Plus, just the 5. So you can add that printer to your settings, and that will have all of the setup information on bed size, print speeds, and everything that you need to get started. If we have a different printer, well, maybe we'll be using different slicer software, and I'll tell you about that. If you have a different printer, you'll have to set that up for your printer. But again, you don't need me to tell you that if you've got your own printer. Okay, anyway, this is where we're going to get. And this is where we are right now. We have a whole bunch of nodes, and we want to get them out, and we want to get them into Cura in the easiest way possible. Okay. Here we go. Alrighty. So I'm in here, and I can rotate around a little bit. And what I'm going to do is I'm going to look at my project right from the end. And I'm going to export this in 2 halves. And the reason I'm exporting it in 2 halves is because I've got flat surfaces right here. And because we started on the top, drawing on the top plane, one set of these surfaces doesn't have to be rotated at all. The other set of the surfaces has to be rotated down that way so that it fits flat on the print bed. Okay, so let's start this out. Now, we don't want to print the bamboo skewers. So make sure you come in to your bodies and turn off the bamboo skewers. You should just see the nodes right now. It's possible that your sketch might still be turned on. Okay, so if you still see the sketch there, you can turn off the sketch. It's possible that you might have a construction plane turned on. So if you see a construction plane like that in the middle, you can turn it off. Not that that would be exported, it's just nice to get rid of it. Okay, now what we're going to do is we're going to export this half of our truss first. And in order to do that, we are going to highlight everything on this side. And I am going to right click on one of those. And I am going to come down to where is visible. Show hide. It's right down here. And you see that little eyeball? I'm just going to turn the show hide. And you'll notice that in our browser, all of those little eyeballs are going to blink off. And boom, I can't see them. They're still there. Just I've turned them off, right? Okay, and that means that I've just got these sections left, right in here. And they all have the same orientation. So whether I have to rotate them or not doesn't really matter. Oh, I should have been working in solid mode, but eventually we are going to come over here, and to get these out of here, we are going to come to the utilities. So come along the top, and in the tab, come to utilities, and then you'll go make. And then you want to make sure that you've got this set up for export, because we are going to export this as a 3MF file. You could also export it as an STL file, but 3MF files just store a little more data more easily. It says object. What object do we want to select? Now, if you come in here and try to pick them up one at a time, you'll only get one object at a time, and you'll have to do like 26 different exports. So what we want to do is come over here to our browser and come up here and just click on bodies right up here. This is going to export all of our bodies, but only the ones that are visible. Okay, so it shows you all of the bodies, but you'll notice that the ones that we're exporting are darker. Okay, those are the ones that we're going to kick out right now. And if we selected everything right, this should be good. So we're going to go export. I like to export as a 3MF file. If it says STL, you're fine too, but let's do 3MF. We're going to export them all as one file, so we don't have to bring them in one at a time. And we'll just hit OK. Now, this window is going to pop up right here. You're going to turn on Save to My Computer. You're going to pick a folder that you want this file to go to on your computer. And I'm going to export this as my YouTube demo truss. Oh, I'm on to version 14 already. And I'm going to call this one side of the truss. I can't remember if it's the side that needs rotating or not, but I'm just going to save that. Bang, there I've got one side of the truss. Okay, and now I'll come in here and I'll turn all of these ones back on. Make sure you get all of them. I think there's probably a faster way to do that, but anyway, just check that all out, and they're all turned back on. And now I am going to turn off the other side of the truss. Oh, make sure I turn off the bamboo barbecue skewers. I do not want to export them. We put a lot of work into using them to create holes in our nodes. Okay, and so now what I'm going to do is I'm going to highlight all of these ones that I just exported, and I'm going to right click on one of them, and I'm going to go show hide, and poof, they have all disappeared now. And now when I go and do my utilities make export, the object that I select will also be bodies, but you'll notice this time all of these ones are turned on, and I'm just going to say okay, and YouTube demo truss V14. I'm going to call this other side of the truss, and there we go. That's off to Fusion 360. I'm going to turn these all back on. And I have now extracted all the information that I need from here, and I can actually hit save. And I think we're pretty much done with that truss. We can close Fusion 360. Well, I don't want to jinx myself. I'm just going to minimize it. All right. Now, hopefully you've had a chance to get Ultimaker installed on your computer or your choice of browser, slicer, and you've had a chance to get it set up so that it says Creality Ender 5 right here, or whatever printer this is going to be coming out on. Okay, and now we're going to come in here and we're going to go File, and we're going to open a file. And I called that, let's just search by date modified. Here's one side of the truss, there's other side of the truss, and you'll notice they're in 3MF format. I'll start with one side. And in this version, it brought all of those parts in, and you can see these ones all compacted down onto the print bed. Now I can rotate around and change my view. The right click button lets me rotate like that. Center mouse button is zoom in, and if I hold the center mouse button, I can pan. Okay, what I'm going to do here is I'm going to pull that up, zoom out a little bit, and use the left mouse button, right mouse button, and just go select all models, because I've picked everything up in here. And now over on this side, I have move, I have scale, don't touch scale, and I have rotate. And I'm going to take rotate, and I want to flip this around. If you look at it right here, all of these ones are upside down right now. I'm just going to rotate them all 180 degrees. Make sure you get that 180 degrees. That looks really good. And now you can see that because I rotated them around, they're intersecting with each other. So right click on one of them, okay, and go Arrange All Models. And Arrange All Models should give each of them their own space on the print bed. You can also rotate down here, and you'll notice that they're all showing nice flat blue sides on the very bottom of the print bed. Those little stripes of red are areas where it would like to provide some support material, but we're not going to need that. The printer can manage getting by without a little bit of support material. We've also aligned these so that we're going to just print straight upwards here. Everything's flat on the bed, easy to print. This is about half of what we've got to print. It's going to be a full print bed by the time we're done, because now we're going to come in here and we're going to go Open Files, and we're going to do the other side of the truss. And thankfully for our case, the other side of the truss comes in really nicely, and we don't need to rotate it or really do anything with it. We can see nice big flat pieces on there, but we do need to come in and right click and go Arrange All Models. And you see it says it can't find a location for that one piece, and we've got one or two pieces that aren't showing up as light blue. We'll deal with them first. Okay, so if you're seeing something like this, pick the piece that's not showing up as light blue at the bottom, come to Translate, or Move as it's called in here, and just lift it up in the air and let it drop down. And it should be showing as blue on the bottom. So I'm not quite sure what's going on and why that's not doing it. Thankfully, there's another way that we can get that to show nice light blue surface on the bottom. We can come in here, and if I pick that piece and come to rotate, this icon right here, select face to align to the build plate, and I can come in here and tell it to align that face to the build plate, and well, I guess that's as aligned as it's going to get. Looking in that way, it seems pretty nicely matched to the build plate. You can see these ones over here are a little bit low. Those ones, I'll need to lift them up and drop them down. That one turned nice and blue, and that one turned nice and blue. This one's still giving me a bit of fussiness for some reason. There we go. It's nice and blue now. All right, but we're kind of stuck because we've got one that's not quite on the build plate. The computer couldn't quite figure out how to fit it in there. So what I'm going to do is I'm going to look at this from the top. So under View, Camera Position, Top View. Now I can see everywhere where I've got a little bit of space, and I'm a little bit hamstrung because remember we had two nodes that were really close together. They're actually going to print together. I don't know how you're going to be able to get your skewer in there. You might just ended up having a 3D printed node for that one. Wasn't my intention, but that's how it's going to work out for some of these trusses if you've got really short pieces close together. Okay, so what I'm going to do is I'm just going to click on move. I'm clicking on this piece that's not on the bed, and I'm like, where can it go? Now I can't overlap it with anything else because that would be silly. They'd be all stuck together, but there might be a bit of space if I rotate it. So I click on rotate, and you can see I've got different axes showing right here. I'm going to bring that, and if it's moving in big glops like that, you can turn off the snap rotation here. And like not everything we made is going to be perfectly aligned. That looks pretty good. And now I can come back to move, and well, you can just click on it, slide it in right there. And that looks okay. Now, because I told it I wanted to see the top view, I can't get away from that top view. I need to come in here, and if I want to change my camera position, I need to change it back to the 3D view. And now I can pan around. That one's showing me blue right there. Let's lift it up and down. And there we go. Now it's snapped onto the build plate. It's looking really good. We should be able to print that, no problem at all. And just a little double check, you can see that we've got some 3.2 millimeter diameter holes, some 5.5 millimeter diameter holes, in other words, big holes and small holes, and at least one of these parts should be filleted. And if I look at the bottom right here, do I see a 3 on one of them? I can't remember if I saved that 3 or because it was an optional video, I just let it go. Oh, now see that one right there? We could break that apart afterwards, but I don't think those two are supposed to be connected. Yeah, that doesn't look right. What the heck happened right there? So let's just try taking move and moving this one a little bit away from there. That looks better. And do take a moment to make sure that you've got everything into place and that it all makes sense to you. We've got two matching parts that are kind of print and stuck together. They weren't meant to be that way, but it looks like they are going to be that way. They might break apart for us so we can get a truss in there. Anyway, I'm obsessing over that at the moment, and we've got a video to do. So now you've got all your parameters in here, and you know what? Standard quality 0.2 millimeters is gonna be fine. A couple of tweaks that will make it even better than fine, so you can come over here and use standard quality. Now yours might need to have a drop down right here, so you can come in here and click this. If you're not seeing what I'm talking about, just look in here. You've got some settings. There's standard quality, super quality, all these different quality levels that you can get to, and basically that is fancy ways of saying your layer height. So I'm going to show you a couple of different things that we can try in here. The first thing I'm going to say is let's change your printing temperature up a little bit. I find my printers work with PLA a little nicer at 205 degrees than they do at 210. Or sorry, at 200. You can tweak this on the printer later on. We're also going to change the build plate temperature. We could go up to 60. Okay, 55 works nice sometimes too. I've got some glass plates that work really nice at 60 degrees. Just that little extra heat lets the bottom layer of plastic bond really well. And because we're going to have a lot of small surfaces on that bottom layer, we want them to bond really well. Speed, you don't need to adjust. Travel, you don't need to adjust. Cooling, you don't need to adjust. Generate support, you definitely want that to be turned off. Okay, because otherwise it will put support material inside of all of your inside your nodes where you want to put bamboo barbecue skewers. So don't turn that one on. Build plate adhesion type, I like skirt. Okay, but if you're having a hard time fitting everything onto the bed, you could tell it none. Okay, and when you tell it none, that will free up a little bit more space around the margins. You'll just have to remember, if you tell it that you're going to have to be really careful when you print to stick around and watch that first layer get stuck down to the bed. Okay, we don't have dual extrusion on this printer, so you're all good. Once you've made those couple of tweaks, you can click on Slice. And the computer will think away right here, and it's going to tell you it's going to take 19 and a half hours to print this out, and it's going to use 132 grams of filament. So I'm not worried about that right now. 1 kilo of filament is about 20 bucks, so you're using maybe $3 worth of filament for this project. Could start to get expensive if you're doing it with a high school class and a couple iterations of trusses. But by and large, a couple dollars on bamboo, a couple dollars, a few dollars on the nodes, and you're probably going to do okay. Now, what's really cool when it tells you this is that you can also click on Preview. Everything's going to change its appearance a little bit. And zooming in right here, you can actually see the individual fine lines that the 3D printer is going to be printing. And if I come over to the right-hand side of the screen, I can drop it down layer by layer by layer. And what you're seeing in the middle right there is what we call support material. Most 3D prints are hollow on the inside, and they're just, not support material, infill material. So this orange material right in here is infill material. And most 3D prints are pretty hollow on the inside. Like there you can see there's just a mesh on the inside. And where your strength usually comes in is in the outer wall thickness. Now if I zoom in a little closer here, there we go. You can see that right now I'm only getting 2 passes of the nozzle on the inside and on the outside right here. And I'd like to increase that to make it a little bit stronger. I got a couple of ways. One, I could just tell it that I wanted 100% infill and it would solidify everything right in here. But even before it does that, I'd like to get a couple more passes right in here. So what I'm going to do is in my settings, I'm going to come right back up here and under wall thickness, okay, I'm going to make it 1.6. Now in here, I'll usually use multiples of 0.4 because I have a 0.4 millimeter nozzle. You're not required to, but let's see what it looks like with a 1.6 millimeter wall thickness. It's not going to take that much longer. And now you'll notice that when we're looking in here, that this is going to be solid all the way through. This is one of the parts that tends to break off. So instead of having infill in here, I'm pretty happy to be having solid material coming all the way up there. And then when we hit here, well, we get a little bit of infill right in there, but not nearly as much as before. Now, if you wanted to make this just a little bit stronger in here, you could come in and change your infill density. And let's change our infill density up to 40%. And then you can slice it again, and we can see what that looks like. Now we're up to 20 hours and 176 grams of filament, and you can see that that orange pattern in there is a lot more dense. If you want to see what happens when you try 100% infill, which you're welcome to try on this project. Normally I would advise against it, but strength matters here. Slice it 100% infill. And we're up to 20 hours on here. So not so bad. You can put that on in the evening before you go home, and it will be finished the next day when you come into the shop, and you'll be able to take all these pieces and build your practice truss. Ultimately, you'll be able to have all these pieces given to you, and you can figure out how to piece them together to build your final truss. If all of your pieces don't fit onto one print bed, we may have to print a second print bed. So you can set your file up and export one side of the truss, put that on one print bed, export the other side of the truss, put it on the other print bed. It's a little bit more work, takes a little bit more time, but if you've made a heck of a lot of nodes, you're not going to fit them all on one print bed. Okay, so if you need 2 print beds, do one side of the truss on one and then save that file, and then the other one on the other side. Now, for my students, I'm going to ask that when you get to this stage, you probably want me to take a look at this, because this is like probably your first time 3D printing, and I'll go over it with you. And if it looks something like this, it's probably going to be fine. Okay. And when I say it's fine, what you'll do is you'll go to the Creality Ender 5, you'll get one of the micro SD cards off of there, and you'll come back to your computer, plug the micro SD card into your computer, and then you will save to the removable drive. A little option will pop up in here, or you can just click Save to Disk, and you can save that G-code file onto there. Make sure it's the G-code file, because that has the instructions for the 3D printer on how to print your file. And yes, it is the same G-code that you're learning about in your CNC machining class. One or two different additions on there. Okay, so once you've got that done, save that, okay, to whatever file's going. You can save it to your drive, and then you can just transfer it onto onto the micro SD card later on. Plug that into the printer, press print, and for the next 20 hours, you don't have to worry about anything, because the printer will be hard at work making your truss for you. Okay, good idea before you close this down is just to hit Save Project. Okay, and I'm going to hit both sides of the truss in here. Oh, yeah, helps if I save it back to my folder, not to my C drive. Where is my Dropbox on here? It's way up here. That's the instructor. This is where I'm keeping all my stuff. Bamboo skewers, both sides of the truss. There we go. So the 3MF file contains, it's kind of like your source code, and the G code is kind of like your machine code, because that's going to the machine. Alrighty then, things are saved. This is done, and holy smokes. Thank you for watching this video, and I hope you have really good luck with your truss. Looking forward to seeing them come together.